Welcome to the On-Premise IT Roundtable, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth, and I'm a member of Gestalt IT, and each episode we bring you a group of industry experts with various opinions on some interesting topics, and we pick one of those, a premise, if you will, and we try to stick to it for the entirety of the podcast. But, sometimes we get into some interesting discussions. I'd like to take a moment for our guests today to introduce themselves and give you a little bit of information about who they are before we get into today's premise, starting with Jake.
Hi, I'm Jake Snyder. I'm a corporate systems engineer at Juniper Networks in the PLM team. You can find me on Twitter at jsnyder81 and my blog at 2dsfromds.com. All
right, Ali.
Hi, my full name is Mohammad Ali. I go by Ali. I'm actually a senior wireless engineer for an organization called ENA. It's focused towards education sector primarily. My blog is artofrf.com, and on Twitter, my Twitter handle is MALIEF46.
All right, and last, Sam.
And certainly least. My name is Sam Clements. I work for a large VAR here in the States called Presidio. I look after the mobility practice. You can find me on Twitter at Samuel_Clements, and I blog at sc-wifi.com.
All right, thank you all for joining us today. Let's jump into the premise for today's episode. Wireless planning is not exactly a cut and dried thing. There's a little bit of art to it, and there's a little bit of science too. And every so often we have a shift in the way that we look at things. Maybe it's a new protocol coming out that gives us some opportunities to make different design choices. Perhaps it could be different building types, moving from a small school district to maybe like a large venue, like a stadium or an arena or something. Sometimes we create rules of thumb that help us in the planning process, but maybe aren't the best design decisions. And one of those rules of thumb involves data rates and cell sizes. Now, the premise for today's episode is that data rates don't change cell size. And I know that a bunch of you are already running for the comments because you're ready to make a comment about whether I'm right or wrong, but I'm actually going to let our guests jump in here. And I'm going to start with Jake, because Jake is the one who actually brought this premise to us a long time ago. And we're finally getting around to it, mostly because, we have the opportunity to kind of dive into it a little bit, but also with some of the latest advances in wireless technology like 802.11ax and 6 gigahertz, I wanted to see, is this still a valid premise? Jake, why do you think data rates don't change cell size?
Well, I think the general thought process is that by trimming those rates, we shrink the cell or shrink the range at which you can demodulate a beacon and control plane packets or frames. And I don't feel that actually has a good effect on the cell size. There are tons of other ways to control cell size, but I feel like that just doesn't actually move the needle, so to speak. So.
All right. So you're saying that there are a multitude of other ways if I wanted to do smaller cell sizes, say for, I don't know, like a stadium, where I was more worried about density as opposed to coverage area, because sure, I don't need wireless coverage on the field. I need it in the stands, but I'm trying to play with the way that works. But why would someone be tempted to use data rates as the cell size deterministic system?
That's a good question. I think it comes down to how we measure. When we measure, most of us are familiar with getting a site survey tool, Ekahau, IBWave, NetSpot, and walking around and measuring what I can hear for Wi-Fi. And by changing the basic rate and by changing the rates that I allow on that particular wireless LAN, you do definitely change the distance that you can demodulate that beacon. And so someone can go and say, well, look, see, I changed the data rate and my picture got smaller. And it leads us down this path that, I changed the cell size by doing that. And it definitely can look that way, but did the RF stop at that point? No, it continues on. It's just, you can not necessarily measure it or quantify it at that point because you are no longer able to demodulate it.
I'd say that's probably pretty fair. And again, it comes back to that whole rule of thumb idea of, well, if I click this button, things get smaller. So, Sam, you've had a lot of experience designing Wi-Fi, and I don't necessarily know that you subscribe to the data rate cell size pairing. What do you think about this?
I have lots and lots of thoughts, and of course, it's obviously a nuanced conversation. I think that as Jake said, when you mash the button and you look at the picture and the cell or it looks like it's smaller, what he's saying is obviously you've hit a point at the boundary where you can no longer demodulate frames. I think at that point we would call them ghost frames, right? They're no longer demodulatable, but we have an assumption that they exist despite the fact that you can't measure them, you can't actually see them. And I think that was probably the premise of the whole conversation behind ghost frames way back when it happened. But I think that there's a lot of potential for changing a variable in the equation and then having the output be true instead of false. Like if you are, for example, walking around with a native and B only wireless client and you have trimmed the 1 megabit per second data rate, guess what happens when that client hits the 2 megabit per second data rate and it finds the edge of that cell? It stops working because 1 megabit per second is no longer supported. Now, the reality is obviously how many of the B wireless clients do we really have in play? The number is small, but it's the exceptions that really define the rule, I think, in my book, and that's just sort of expected behavior. If you start talking about things where there are unexpected behaviors, such as AP manufacturers not implementing CDD for cell smoothing and things along those lines. Yeah, you absolutely can run into situations where you're looking at different cell sizes, and that cell size that you're visualizing is directly impacted by the data rates that have been configured on your infrastructure. Whether that's expected or unexpected behavior, I think is probably beside the point. But your cell sizes absolutely can change. Whether they should change or whether you want them to change is an entirely different story.
See, you're making me wistful for the whole world of Ethernet, where my cell size is a wire that runs through the wall. And unless I've got real problems in that wire, the coverage area is not any bigger than that wire. Now, of course, I run into the problems of having to plug the wire into my laptop and run around with it if I have connectivity and stuff like that. But I want to speak maybe a little bit to your example data rates of the 1 and 2 megabit data rate conversation, because as we know, those are very old data rates, like 802.11b era. And we know for a fact that when we enable those older, slower data rates, we do increase coverage area, but we also reduce the throughput of all devices that are connected to there, because the possibility exists that my brand new MacBook Pro at the very edge of that cell may be connected at a 1 megabit data rate. And I've seen recommendations from wireless professionals in the industry that rather than designing around a different data rate and shrinking your cell size, you should just start turning off those older ones and forcing your clients to use the newer, faster data rates, and that effectively creates smaller cell sizes because you lose coverage past a few dozen feet from the AP. Is it smart to turn those off? Because I know that I've run into problems with that in my own personal use, but that's mostly from legacy equipment.
I disagree with the premise that that wired networking doesn't suffer from this problem, because the reality is it absolutely does. I absolutely have done deployments where I have a 105 meter cable, 105 meter long cable, and if I try and bring that link up at gigabit speeds, it doesn't work. But guess what? When I hard code both ends to 10 meg half duplex, link comes up just fine. What have I done? I've effectively increased my cell size by using lower data rates. Absolutely. I just happen to be doing it over a cable.
Touche. I'll give you that. And having been on my fair share of those 305-foot deployments and wondering what's going on and having to hard code speed and duplex on an Ethernet cable as actually one of the very first networking things I did as a professional, I see your point. I think maybe it's a little less touchy-feely, a little less artistic. I mean, Ali, your blog is The Art of RF. You've done a lot of these wireless deployments. is this cell size data rate conversation one that you have to have with customers, or do they just say, you know what, you're the expert here, you've configured it the way that it's supposed to be done, we're not going to fight about it?
Thank you, Tom. I feel like there's two different parts to it. One part is obviously depends on the customer, right? Obviously some customers are highly technical, some are not, and most of the time I do end up having this conversation, and there's whiteboarding sessions and all that kind of stuff. So first part is obviously when the cell size of RF, where basically the PLCP headers, right? Like how far that goes. And the second part, I think, is data rates. They can affect in a way where if I have a client, for example, connected to an access point, and they're both let's say the client is maybe 3 meters away from the access point. As the client moves away, and if the lower data rates are enabled, well, client will actually stay connected, just like you use the example of a MacBook, right? It's connected at 1 meg, for example, and it's far away. Well, the client will also create interference, actually, and that could be that could go really far away as compared to versus if you have a higher data rates enabled. Now the clients will not be able to go that far and stay connected to that access point. So that indirectly, in a way, you can kind of shrink the cell size in that manner. But overall, you're not really shrinking it because you're not affecting the power level of that access point.
One thing I like that you brought up is that it doesn't change the effective boundary of impact. Like clients create impact zones around themselves in terms of what their cell of impact is. It doesn't change that. And one thing that we don't do is when we change those data rates, we're monkeying with both how the client hears the cell, and we're monkeying with how the client can talk back to the cell. And I feel those take a lot of nuance in terms of stability of connection. I start saying you have to talk at a much faster data rate in order to acknowledge frames and maintain your connection to the access point. Suddenly we can run into more stability problems as well, even within the effective cell size. And so changing those data rates, when you look at it, it's much safer to do them with things like antennas and transmit power than it is with, monkeying with data rates that also have stability and performance impact. Do we get more airtime by trimming all those rates? Yes, but it doesn't necessarily mean that the stability of those connections are still the same.
But this isn't an issue that was necessarily unique to wireless. I mean, we see this in LTE and 5G connectivity as well. When you're on the edge of a cell, or when you're in an area where the data rate is a little bit lower, I mean, it's problematic when you have a stable but very slow connection. Whereas, would it be better to have a higher data rate requirement as a minimum to force you to fail over to a different transmitting device, whether it's an AP or a tower or something, to help with quality of experience? Because how many times have we gotten that phone call, oh, the network is down? No, the network's not down. You're just connected, essentially, as Sam said, at 10 half duplex. It's just running really slow for you. So in essence, could the data rate conversation, even though it shouldn't have an impact on the cell size, actually be a better quality of life improvement for people overall?
I just want to point out that Tom just said that LTE and 5G are not wireless technologies.
They're not Wi-Fi technologies. How's that?
Wi-Fi technologies. There you go. There you go. No, it's the same. It's the same problem that we run into in the physical medium space. You have a finite amount of physical transport, and that finite amount of physical transport, by leveraging modulation, is what gets you bits from point A to point B. Look at N-base-T cables, right? We have an N-base-T cable specification. We have devices that say, hey, despite the fact you've got a 100-meter cable, that cable might do 10 gigs at 50 meters. It might do 5 gigs at 75 meters. It might do 100, whatever, right? You may get different performance out of different cable lengths, not just by virtue of the fact that it's a cable length problem, but by virtue of the fact that it's a cable quality problem. And length of a cable adds to that physical medium, and it just becomes a math problem, which is a modulation on top of that. You need more you need more spectral capacity in order to transmit bits, and that's how we get bits in and out of the air. There's this whole concept of soft landing that I see discussed in LPVs and stadiums, where you are monkeying with data rates in order to get a client to sort of to roam not gracefully until it gets into its seat, and then be more okay with landing wherever it's at. But gosh, I think the problem goes way beyond that. I think especially when you start talking about defects in products, you start talking about crappy antennas, terrible third-party antenna manufacturers, people who are building radios and drivers that are turning features on or not, that are meant to smooth some of these things out. And the challenge is I don't know that anybody is making infrastructure gear today that was making infrastructure gear 5 or 10 years ago. Now, organizations are, but the people aren't. And I think this is across the industry. The people who are making Wi-Fi 6E products today never built an B access point, right? The people who have the propeller hats and the Coke bottle glasses, right? Those same people aren't the same people who have that legacy heritage that has always been in play. And so now we're talking about building 20-year-old specification into product that people have never touched before. And I think that's from the top down. It's all the major players. It's Cisco, it's Aruba, it's Mist, it's all of them. And that becomes a problem for us, especially with these legacy compatibility issues that we're running into that drive all of this client behavior for us.
I would say you've seen a similar problem in a lot of other places in the networking space where people who have not had experience with low speed networking, whether it's ISDN lines or very tiny Ethernet connections, will want to go back and rewrite routing protocols because, OSPF is inefficient because it sends really small hello packets. If we sent really big hello packets, then we could exchange the whole table at once. And we're like, yeah, you've never tried to send a 1 meg hello packet over a 56K link, and it shows. So yeah, I think that you're right that a lot of the people who are currently looking at building these technologies are like, yeah, who would ever use a 1 meg data rate? And we're like, back in 2004, that's what we had. You didn't have any other options. So is there an education aspect to this? Is there we're going to turn off all the high data rates and make you guys learn to live with, the low stuff, the 5.5 meg data rates for a little while. So now you know what it felt like back in the early days and you're more willing to kind of look at other options? Or are we just going to let folks who think that the past is a cute little thing to read on Wikipedia dictate how things are going to work in the future?
Well, and I think there's an interesting opportunity that we're approaching right now with 6 gigahertz and Wi-Fi 6E, in that we don't necessarily have to carry all this legacy baggage with us. I mean, think about one of the things that always kind of boggles my mind with 11N and AC and even AX is that we still have these OFDM data rates that we deal with. And it's like, okay, here's your 1 through 54 that you get to define. And when most people talk about trimming data rates, that's what we're talking about. And that has zero impact on all these MCS rates that we've been layering on. So while you said, I made 54 the minimum, that client can still use 7 megabits per second because that's an N MCS rate, right? And so I feel like not only do we have some challenges in all this legacy stuff with that and MCS rates and traditional data rates not, necessarily obeying by the same rules, but now we get into Wi-Fi 6E when we're in 6 gig and we don't have to deal with legacy stuff. Is that, suddenly now we're WPA3 only. Is that our break point where we can send really big routing packets and not have to worry about backwards compatibility with, like ThinNet? I don't know. But I'm hopeful it's going to get better.
The reason behind disabling low data rates to begin with, the reason this is even a concept in our industry is because of inefficient modulation. And when you have too many SSIDs or too many radios and you are chewing up airtime inefficiently, this isn't the problem of, hey, 1 megabit per second takes 1 megabit per second and 12 is 12x the speed. It's different modulation types, right? One is CCK modulation, one is OFDM modulation. And OFDM modulation is far more efficient than CCK modulation, not just in speeds and feeds, but you use less air at the same data rate with OFDM modulation than you do CCK modulation. So the whole point of getting rid of low data rates is to decrease spectral load or increase spectral efficiency by getting CCK modulation out of the air. And when you get rid of CCK data rates, the only thing that's left is OFDM rates. And that's OFDM rates from native to 11G all the way on through to Wi-Fi 6E running in 6 gigahertz. The spectral impact to disabling OFDM data rates is negligible at best. Diminishing returns is where you're at here. In my book, Disabling Low Data Rates is about getting rid of CCK modulation, not about getting things faster. And the people who are like, oh yeah, I disable up to 36 megabits per second or 54 megabits, none of that garbage matters. None of it matters.
So just want to add a little bit to that. I think that there's also a consulting and kind of like a design aspect to all this as well, right? I think optics matter at times as well. So I've been in situations and designs where users will at times, so there's higher data rates, obviously, and the coverage is not like, 100%. And there's some coverage gaps and all that kind of stuff. And users can see, oh, I only get like, 1 bar or 2 bar over here. So again, that's where I'm talking about optics, right? Because they're looking at the bars. So now if you enable 6 meg, okay, like, now they can connect a little bit more further. They can see more bars, and they're not as concerned about like how fast, like, they're not going to fast.com or speedtest.net or running some kind of iPerfs and all that kind of stuff. They look at the bars and they're happy. Oh, I got full bars. I'm very happy. I'm getting that. So that, I think that also plays a role in here, depending on, again, the environment and the customer.
Can I put on my way back hat for a second? Because when we upgraded our modem banks from 28.8 modems to 33.6 modems, and you know how many phone calls I got from people who were like, yeah, but when I connect, it says 28.8, not 33.6, and I want that speed. They don't realize that's an initial dial-up connection speed. And in order to actually figure out what speed you're connected at, whether it's 56K or one of those intermediary speeds, you have to actually stress the connection. This is not a new problem for us. So the optics of, oh, I connect slow because the gauge looks bad, is something that we've been dealing with for literally since the days of dial-up. It is just as irrelevant today as it was then, I guess, is that not to speak badly about your comment there, Ali, but those aren't real tangible problems.
Yes, but how many times have we fixed an issue with a customer, as Ali said, where we turned on something that theoretically would reduce the customer experience from a behind the scenes perspective, but it makes the optics better, so everybody's happier. I mean, I've done that where, like, you turn on Outlook syncing so that your Outlook opens up right away, as opposed to waiting to pull all the messages down from the server, because when your mailbox is gigabytes and gigabytes in size, it takes forever. And suddenly now everything is so much better, even though, there's delay in email and all that other stuff. I mean, IT is full of these solutions, if you will, but how does that impact design? I mean, do we compromise our design for our users? Because ultimately, think about designing Wi-Fi in a large public venue. If nobody comes to the stadium, there's no reason to have Wi-Fi. So do we look at this and we say, okay, well, we're going to make these design compromises and thoroughly document them, because it makes our users effectively happier, even if the purity of our solution, because we designed this perfect setup with the perfect antennas and cell sizes are the way that they should be, but somebody says, well, when I'm sitting in my seat, I only have 1 bar of connectivity. How far do we take that?
Well, anyone who's ever had to turn on 40 megahertz channels because the boss wants to see the number knows that all of these decisions are compromises, and we run into perception is reality a lot. Like, I did a hospital once, and I went in. They had a terrible design. They had brand new equipment, and the answer was, we have to replace all the APs. And I'm like, but we can fix this. We can just move some APs around and it'll be fine. And they're like, no, you don't understand. Like, they see that box on the ceiling with that logo and they associate the terrible experience. You could fix it. He's like, we'll still get tickets for the next 3 years saying that the Wi-Fi sucks. And so sometimes we do these things for the optics of it, because the perception is that, more bars equals better, when we really know that what bars mean is just a subjective number to make you feel good, right? And we sometimes have to balance that, right? Sometimes I got to deploy 40 megahertz channels so the boss feels good about seeing the big number and he can show that off on a Zoom call, right? Those are kind of the some of the compromises we make, in addition to like, well, I'm going to trim some data rates for better efficiency, but not necessarily like shrinking cell size. I'm going to control that with, my RF design, my antennas, my transmit power, all of those things that we should be doing for design. And then sometimes we say, well, I'm going to compromise and enable that one extra rate so that people see a better experience, or people get a better perception of what we're doing. I think it's that way in IT for everything.
I was just say, so I think it also depends. Like, there are compromises. I mean, there's budget constraints involved, and in all this too. But at the same time, I only try to go and push it to the point where I feel like it's not going to create a chaos, like in the end, right? So you can only push it to a certain limit at the same time. So, there's always a conversation with the customer on this. Okay, more bars does not mean always good, or all green does not, in an Ekahau heat map, does not mean always good, because you can have all the bars showing good RSSI and everything like that, but the quality of signal at Sonora is like really low, and it's then those bars are not going to help you, right? So you kind of have to sometimes balance it out too, and figure it out what works, and if it's a best decision for that customer. Okay, if I enable 6 meg, they will see good bars, and will they still at least meet the certain SLA so they're happy with that? It gets complicated, and you kind of require some testing, and you have to figure out where you want to actually exactly set those numbers.
So I think we've pretty much hunted this premise right into the ground, that cell sizes should not be dictated by data rates. But somewhere out there in the near future, some wireless architect is going to be playing around in their planning application of choice, and they're going to be tempted to click that button to remove a data rate, to shrink the cell size. And hopefully there'll be a little voice in the back of their head that says, don't do that, do this instead. I want to ask our experts here. Jake, what should they do instead? What's one thing that they should use to manipulate cell size that isn't changing the data rate?
Antennas.
That's pretty cut and dried. I like that. Sam.
Power.
Okay. I could see that too. Ali?
There's only one other thing left.
I have, well, I don't know if that's what you're thinking or not, but I have utilized actually the building environments, a lot of times to actually, manipulate with my cell sizes and the wave propagation.
Prior to deploying your RF, you pick location first, then you pick the antenna, then you change the power level. After deploying your AP, you change the power level, you change the antenna, you change the location. You do them in reverse order depending on where your assets are at in the ceiling. And Ali, I think, buttoned that up very, very nicely, which is location, right? That's what you do.
Actually, that just reminded me, and one of my CW NE essay was on this topic as well. Actually, one of them.
I think that this is a great way for you to look at one of those rules of thumb that gets used all over the industry and say, there's got to be a better way of doing this. So remember that the next time that you're in your planning application and it looks like there's a simple solution to this problem, it's probably not as simple as you think, and there's probably a better way to do it. And the next time someone suggests to you to do it that way, maybe you could show them this episode of the On-Premise IT Roundtable and get a little bit of education about why that's a bad idea. All right. Well, I want to thank each of our guests for being a part of the podcast today. You can always find the latest episode of the On-Premise IT Roundtable on our website, gestaltit.com/podcast. You can also find us on our YouTube channel at youtube.com/gestaltitvideo. Why don't you go ahead and subscribe and turn on notifications so that you'll know when the latest episode gets published, as well as some of the other things that we do, including unboxing videos and longer form video essays like Conversations and Checksum. You can also subscribe to our podcast in your favorite podcast application of choice. choice. You can also subscribe to us on iTunes. And if you do that, please make sure you leave us a rating and a review, because people actually do read those things, and that helps them understand what we're all about, that we are using the word premise correctly here, and that they should definitely take a listen if they're into enterprise technology. We should be back in a couple of weeks with another great episode, and I want to hope that you will all tune in for that. But for now, for myself, Tom Hollingsworth, our great guests, our staff here at Gestalt IT, and our wonderful community, thank you very much for tuning in. And remember that we will be back very soon.